Hello students, in this video we are going to talk about a comparison of alkyl cyanides and isocyanides from the point of view of structure, physical properties and methods of preparation. Okay. Now have you heard the term cyanides and isocyanides and what does it mean to you, right? See, cyanides and isocyanides are alkyl aryl derivatives of hydrocyanic acid. It's a very poisonous gas, okay, and they differ only in the way in which the cyanide moiety is attached to the alkyl aryl group. See, the cyanide group is a bidentate group, okay, can attach both by its carbon, in which case, to the alkyl group, in which case it forms an alkyl cyanide, as you can see here, RCN, ARCN, or it can form an isocyanide, in which it is attached through its nitrogen atom. So, in this case, the nitrogen becomes tetravalent and holds a positive charge, and the carbon becomes a carbanion, okay, RNC or ARNC. So, isocyanides are also called carbylamines, by the way, okay. So now what are the physical properties of these two compounds? Thus both compounds, cyanides and isocyanides, bearing the same alkyl aryl groups, are structural isomers, right? They are structural isomers, okay. The cyanide carbon is electrophilic, because the triple bond C triple bond N, it's polarized, while the isocyanide, you can see the carbon bears a negative charge, is nucleophilic, okay. Both N and C atoms in both these isomers are sp hybridized, okay, because they got a triple bond there, so it's sp hybridized, and they're linear molecules with a 180-degree bond angle. So okay, so they're straight molecules. Both cyanides and isocyanides are polar groups, okay, and with the lower alkyl homologues of both these compounds, they are soluble in water. They are hydrogen bond with water, whereas the higher homologues are not, because the alkyl group size increases, the hydrophobicity increases, okay. They are either colorless liquids, lower homologues at room temperature and pressure, or colorless crystalline solids for the higher homologues, okay. Cyanides have a very pleasant odor generally, but the isocyanides, the carbylamides, have a very horrible foul odor, okay, very bad odor, okay, like dead bodies. So now what are the methods of preparation? We are looking at some of the methods of preparation for cyanides. So from alkyl halides, you can take an alkyl halide, alkyl chloride, bromide, iodide, etc. Can treat them with sodium cyanide or potassium cyanide, very poisonous compounds. You have to be very careful in handling them, and you get the corresponding alkyl cyanide. But you can't prepare aryl cyanides this way, okay, because this is SN2 reaction conditions, and aryl halides do not react in SN2 reaction conditions, right? So that doesn't happen here. But so you can take an example, ethyl chloride, you treat it with sodium cyanide and you get ethyl cyanide, okay. So now the second method of preparing alkyl cyanides is by dehydration of the amides, okay. You can take an amide, you can dehydrate with either phosphorus pentoxide P2O5 or SOCl2. You heat them and you get the corresponding RCN. So you can take benzamide, you heat it with P2O5, right, and you get the cyanobenzene, right. So that's what you get. Now you can also get the aryl cyanides through the diazonium reaction, Sandmeyer reaction, okay. You can take the aryl diazonium chloride salt and treat it with Cn minus, that is potassium cyanide or sodium cyanide, in presence of CuCN, and you get the corresponding cyanoaryl compound, okay. Remember, alkyl cyanides cannot be made this way because the alkyl diazonium salts are not stable, so that's why, okay. So now as you can see, isocyanides, okay, you can make isocyanides also from alkyl halides, but remember aryl halides don't react in this also once again, okay. But here you are going to use silver AgCN, okay, in alcoholic conditions. So what's happening is the Cn minus is going to attach via the nitrogen under these conditions, and you get the corresponding isocyanide, right. So you take the alkyl cyanide, propyl bromide, you treat it with silver cyanide, alcoholic, and you get the corresponding nitrile, okay. And the famous reaction, carbylamine reaction, can make isocyanides from the corresponding primary amine, okay. It's called the carbylamine reaction. This is also a qualitative analytical test for primary amines. You take a primary amine and heat it with chloroform and potassium hydroxide to get the corresponding carbylamine or isocyanide, okay. You can both aryl and alkyl isocyanides can be made this way. All right, thank you, have a nice day, bye.